In this video, we'll learn how to evaluate our binary classification model. We'll use key metrics and visualizations to see how well our logistic regression model predicts loan approvals. We'll start by calculating the accuracy of our model, which is the ratio of correct predictions to the total number of predictions. We'll also look at the classification report, which provides more detailed metrics for each class. Our model achieved an accuracy of 0.8177, which is 81.77%. This means it correctly predicted the loan status for 81.77% of the applications in our test data. While this seems good, accuracy alone does not tell the full story, especially for classification problems. The classification report shows metrics for each class. So for rejected loans, class 0, we have precision of 0.83, recall of 0.97, and an F1 score of 0.89. For approved loans, class 1, we have precision of 0.73, recall of 0.29, and an F1 score of 0.41. Precision tells us what proportion of positive identifications approved loans were actually correct. Recall tells us what proportion of actual positives or approved loans were correctly identified. The F1 score is the harmonic mean of precision and recall, giving us a single metric that balances both. A confusion matrix is a powerful visualization that shows the counts of true positives, true negatives, false positives, and false negatives. The rows represent the actual values, and the columns represent the predicted values. So looking at this matrix, we can see the model correctly identified a large number of rejected loans, but it also made a number of errors in both directions, particularly false negatives. Here we have a breakdown of the confusion matrix components. True positives, TP, cases where the model correctly predicted loan approval. True negatives, TN, cases where the model correctly predicted loan rejection. False positives, cases where the model incorrectly predicted approval when the loan was actually rejected, also known as type 1 error. False negatives, cases where the model incorrectly predicted rejection when the loan was actually approved, also known as type 2 error. So understanding these components helps us to evaluate the model from different perspectives. For example, in a loan approval context, false positives might lead to financial losses for the bank, while false negatives might mean missed business opportunities. Now let's look at our overall precision, recall, and F1 scores to better evaluate the quality of our model. So we're going to calculate precision, recall, and F1 score. And here we have more detailed explanations of the precision, recall, and F1 score metrics we saw earlier. Precision of about 0.73 means that when our model predicts an approval, it's right about 73% of the time. Recall of about 0.29 means our model correctly identifies about 85% of the actually approved loans. An F1 score of about 0.41 balances these two metrics into a single value. To evaluate performance, we also want to look at the receiver operating characteristic, ROC curve. The ROC curve plots true positive rate against false positive rate. The diagonal line represents a random classifier while the curve shows our model's performance. The AUC, area under the curve, value of about 0.736, tells us that our model has okay discriminative ability, better than random guessing, which would give an AUC of 0.5 and follow the dashed line. We can also see what impact our choice of accept-reject threshold has on our predictions. This final visualization shows how different threshold values would affect our predictions. By default, if a prediction probability is greater than 0.5, we classify it as approved, otherwise it's rejected. However, we could adjust this threshold based on our specific business needs. A stricter threshold of 0.7 would reduce false positives but might increase false negatives. A more lenient threshold of 0.3 would reduce false negatives but might increase false positives. The choice of the threshold depends on the relative costs of different types of errors in your specific application. For example, if the cost of giving a bad loan is much higher than the cost of missing a good loan opportunity, you might want to use a higher threshold. All right, so we've covered key ways to evaluate our logistic regression model for binary classification. Just remember, your choice of metric depends on the business goal. If false positives are costly, focus more on precision. If catching every positive case matters, then go for recall. Now you're all set to confidently evaluate any binary classification model that you build.